All right, we're going to play a game, and the game is called Who Can Be Quiet the Longest? All right? All right. We, all right, we're going to do these two examples, and you do have homework from this. So uh, we got to make sure we got this concept straight, though. Particles moving along a straight line with the equation S is equal to F of t, where S is the position in meters and t is time in seconds. Find the velocity of the particle at times t equals negative 4, 1, 3, given the function has position S equals 5t squared minus t minus 3. I don't know what happened really, but what? Just recording the screen. Oh my gosh. All right. So, okay. All right. So here's what's happening, okay? I was at the cross country meet last night. Bo, did you start at the starting line or did you start a few feet back? So you were right up on the line. Oh, okay. But there's not room for everybody to be up on the line, is there? So some people are a little bit ways off, right? Okay. So here's the deal. What we know is that this particle is traveling on a straight line. So if you kind of get this idea, it's traveling and it might actually stop and turn back around and go the other way. And then turn and go this way and the other way. So it's a particle that's moving. And, this might be referred to as a starting point. It might have started back of the starting point and moved all the way over 16. We don't know, really. We could model it and see exactly what it was looking like. But fact is, that's what's happening with the particle. What we want to do is we want to find the velocity of the particle. Okay? What does velocity mean? Close. How is it different than speed? Okay, it also has direction. So velocity has direction. And so you can have positive velocity, negative velocity. If you're traveling in this direction, you're going to have negative velocity. Traveling that direction, you have positive velocity. So that's part of the difference. Now, if I say speed, okay, if I, my wife, she's talking to me on the way home. She's like, how fast are you going? I'm going 70. I'm going 70 what? Miles per hour. So miles per hour. The speed limit on I-35 is 70 miles an hour. So um, you've got miles per hour. That's a rate of change. Okay. And we learned that rate of change can be found by taking the what? It's a great thing we learn in calculus. It starts with a D. Derivative. So you will now associate derivative with rate of change and with velocity. So when it says a particle is moving and we need to find the velocity given this position function, the position function is S equals 5t squared minus t minus 3. The velocity function is the derivative of the position function. So what we want to do is we want to find the derivative of that position function. Once we have it, it will tell us what the speed is at these different times. So we know when we see this prime, we know that that means that we need to implement the limit as h goes to 0 of f of a plus h. What do you get when you plug in a plus h? Minus a plus h? Minus 3. So that's f of a plus h, all right? A lot of people forget this minus a plus h, or they forget the minus 3. Now I have to subtract f of a minus 5a squared all over h. Now we calculate the limit as h goes to 0 of, we will now do the algebra. So this is only algebra now, okay? This, because you're subtracting f of a. This is f of a. This is all f of a plus h. So I want to make sure I distribute the negative sign. So what do you start off with? 5a squared minus all over h. So if we've done it correctly, we've learned that everything should cancel that doesn't have an h. Let's verify that that's the case. 5a squared, negative 5a squared. Negative a, positive a. Negative 3, positive 3. Everything that doesn't have an h cancels. Can I divide an h off? So I now have the limit as h goes to 0 of, divide the h off, you end up with 10a plus 5h minus 1 plus 2. This is where the calculus comes in. The calculus comes in the setup and in this portion right here. We now need to allow the limit to go to 0. Can we do that at this point? If the limit goes to 0, what do you need to get rid of? The 5h, because the h would be 0. So the result is 10a minus 1. So the velocity function is 10a minus 1, or you could write it as 10t minus 1, seeing how time is our variable. Obviously, variables are interchangeable. It doesn't really matter. Whichever one makes sense to you. So now that we have this velocity function, we can now find the velocity at those instantaneous velocity, not average velocity, instantaneous at these given times. Okay? So we have at time negative 4, what's the speed? What's the velocity? Negative 41. I need a label. You would normally say miles per hour. We're going to say meters per second. How about at time 1? 9 meters per second. How about at 3? 29 meters per second. I'm taking negative 4, 1, and 3 and plugging it into 10t minus 1. So before, and this was some of the frustration on people's part, they said, we know how to do all that, but we would like to plug in a right away. Like we'd like to plug in negative 4 right away. Well, go ahead. Be my guest. And then how many times would you have to do this? You'd have to do it 3 times. I had to do it. Okay, I had to do it once. And then I simply just plug the value in at the end. So this is my velocity function. Furthermore, you'll be asked for the velocity function, not simply just a numerical value. Okay? All right, last part. Temperature of a pot of water is modeled by the function C equals F of M. C is Celsius. Okay? What does Celsius measure? So this is temperature. So temperature is equal to a function of what is a minute measure? Time. It's a function of time. Meaning as time goes on, the temperature changes. Temperature might rise, it might decrease. All sorts of things can happen when you have a pot of water. You might be setting it outside to cool on the deck in snow. You might be having it on the stove and heating up. All sorts of options. So explain in simple terms what f prime of m means. So if this is f of m, what does f prime mean? What are some words we've used to describe derivative? Instantaneous rate of change. So this is the rate of change of the temperature. Rate of change of temperature. Now remember, when we first talked about this, we talked about delta y over delta x, the change in y with respect to x. So this is the change in temperature with respect to what else is changing, with respect to time. Does that make sense? So I want to be clear here. If you say the rate of change of temperature with respect to time, the way that you would say average is you would simply insert the word average. If you don't say instantaneous rate of change with respect to time, I'm assuming that that's kind of what you're stating, all right? But if you want to say average, you have to put the word average in front. We're not referring to average here, okay? So explain in simple terms what f prime of 5 equals 10 means. What does the 10 represent? Change in temperature, 10 what? Degrees per minute. 10 degrees per minute at the time, 5 minutes. This is time. This is your temp. So the average, I'm sorry, I got myself. Rate of change is 10 degrees Celsius per minute at the time, 5 minutes. Let me give you an example of what you could not state. And this is what people do on their test, and they get angry when I mark it wrong. Some people say, over the course of 5 minutes, the temperature went up 10 degrees. That's absurd. It could have gone up 100 degrees. It could have gone down 200 degrees. You have no idea. All you know is at that one time, it's rising at a rate of 10 degrees Celsius. Think about if you're driving in your car, and at that moment you just say, okay, what's my speed right now? And you're going 55. Does anybody know how many miles you've covered? No. Do they know what speed you were going 2 minutes beforehand? No, they have no idea. Do they know which direction you're going? No, all they know is the speed at that one time. Here's another mistake people make. They say, on average, over 5 minutes, the temperature is increasing at a rate of 10. Used rate, you'd use 10, but the fact is you said on average. At the time, instantaneous. That's what has to be there. Does that make sense? You understand the difference? Okay. So what I want you guys to do is you have an assignment. I'm simply going to add to your previous assignment 3.1. I now want you to include page 132, numbers 25, 26, and 28 through 30. So there's just 5 problems. There's 2 velocity problems, and then 3 temperature and stuff like that type problems. So, yeah. Oh. Yeah, you're going to need your 25 and 26 are on there, but the rest isn't. So, but I think, what time do we get out of here? Okay, so 4th hour is normal length because of the lunches. Okay. All right, so, yep, so if you guys would like to, then you can go ahead and, if you need to get, well, why don't I just go make a copy for you, okay? Oh, no, there will be no debate about the A lunch.